Sir, for last class we have seen lathe parameters and operations performed in lathe. In this class we'll see lathe turning parameters, and this is the various parts of lathe. This we have seen in the previous class. And the cutting parameters of in a lathe are three. There are three. One is the cutting speed V, and the cutting feed F, and the depth of cut D. And the cutting parameters are explained in this illustration, where you could see n the speed of rotation of the workpiece, and the relative tool travel, which is the feed when for one rotation is pi into d, and the peripheral speed S is pi dn. And the cutting speed V, which is the peripheral speed of the workpiece past the cutting tool, V is equal to pi dn by 1000, and where D, capital D, is the diameter of the workpiece, n is the revolutions per minute of the workpiece, and feed is the distance the tool advances for every rotation of the workpiece, which is given by mm per revolution, and the depth of cut is the amount of the distance between the machined surface and uncut surface of the workpiece. And coming back to material removal rate, is the amount of material, volume of material removed in one revolution, which is given by pi df in pi d into d into f. And there is an example assessment for you. It is I write the process sequence for manufacturing the parts shown in figure from a raw material of 45 mm long and 30 mm diameter. And this thing we already done in the DPS assessment in the last previous class. And these are the possible sequences: turning followed by phasing followed by knurling, turning, knurling, phasing, phasing, turning, knurling, phasing, knurling, turning, knurling, phasing, turning, knurling followed by turning followed by phasing. Out of these, turning followed by phasing followed by knurling is a possible sequence. Turning followed by knurling followed by phasing is not a possible sequence. Phasing followed by turning followed by knurling is a possible sequence, but phasing followed by knurling followed by turning is not a possible sequence. Similarly, knurling followed by phasing is not possible. Knurling followed by turning is also not possible. For these two are the possible sequences. Sequence number 1 and sequence number 3 are the possible sequences. And here, this class, we'll see machining, calculation of machining time. Machining time depends upon the length of the job machined, feed rate, the speed of rotation of the job, and F into N. For here, the total time taken for machining is length of the job divided by F into N. For manufacturing time is the sum of machining time plus setup time plus moving time plus waiting time. So this is an example for assessment to be done by you. Just go through this and solve this problem. And the solution is also given here. It's an example for you. For using this, machining time is calculated to be 3.74 minutes. There's an exercise given for you. It's an assessment. You can do these two exercises. Come to the class with the solution. Thank you.